I am recording, so anything I say will be held against me. All right. I think I've covered, so far, I've covered 6.1 and 6.2. Now, chapter 7, and I'm going to go ahead and tell you, let me go ahead and tell you this. I don't do things according to the syllabus. Y'all know that. I don't color inside the lines. So, I'm going to go ahead and tell you what this test on Unit 3 is going to consist of. Look on your outlines. Get your outlines out for those 3 or 4 people that actually kept them. Okay? And this test is going to consist of section. I don't know why this thing is writing so small. Oh well. It's going to consist of 6.1, 6.1, 6.2, 7.1, 7.2. What does it cover in 7? Look on your outline.
7.1 and 7.2, that's it.
That's it, and then it goes to 8?
Yeah.
Okay. I put Unit 4, I do 8. So 4 sections are going to be on the Unit 3 test. This kind of helps your grade out because they're pretty simple sections, and it leaves Unit 4 for the hard stuff, which is hypothesis testing, which if we waste enough time, we hopefully will not get to. No, I'm just kidding. We'll get to some of it. Okay? All right, so everybody write that down and mark it. Take a highlighter and mark it in your outlines that that's going to be the Unit 3 test. Chapter 8, we're going to move that to Unit 4 with the rest of 8 and 9 or whatever we're going to. Okay? And we covered 6.1. 6.1 is how to find the probability distribution, the mean, and the standard deviation. Mean and standard deviation. 6.2 is what? NP what? NPX, NP, and NPQ. That's what I'm going to test you on. Okay, that's the mean right here. That's the mean, and that's the standard deviation. So it's not like, very difficult math. Most of it, at least, yeah, both of them pretty much are on the, this one you have to use the spreadsheet a little bit or use the columns, remember. Now, these two are going to be on uniform distribution and normal distribution. Okay? So, with that being said, and let me fix this pen because this sucks. Let's try this. That's a little bit better. All right, so you got a graph, and there's 2 kinds of graphs that can go in 7.1 and 7.2. There's 2 types of graphs. We're first going to start with the uniform graph. No, that's uniform graph usually has to do with the only thing that we have no control over. And what is that? I couldn't hear. I heard time. Okay? Even though some people try it, you can't control time. All right? So, usually, uniform distribution has to deal with time. So, most of your questions are going to be dealing with time. Now, one question is, let me go ahead and go over this. The area under the box, or the area under the curve, is always going to be 1. Okay? Because the probability goes from 0 to what? 1. So, always, the area will be 1. So, from here on out, in Chapter 7, the area under the curve, or the area under the box, is equal to 1. Now, they're going to give you the base time. Most of the time, they're going to give you the base time. They're going to say the probability class lasts for, or the teacher usually carries the probability class to 50 minutes. And then for you go, okay, 0 to 50. All right, and then they would say, okay, find the probability that the teacher will stop class 40 minutes. At 40 minutes. That's what they'll say. So let's write that down. Class is usually 50 minutes. What is the probability of the class ending at 40 minutes? Okay. Now, they give you the base time. The base time is 50 minutes. Now, you're talking about 2 or 3 questions on the test. So make sure you know, I don't know. And when we get to chapter 7 and chapter 8, I don't know how many of you have seen this before, because I don't know how far y'all go in high school with the probability. Just like when we get to 8 and 10, I have no idea if y'all have ever seen that before. So I don't know if any of you have seen this before. Has anybody seen this before? Okay, a couple of you have? Okay. All right, class is usually 50 minutes. So what is the probability of 40 minutes? Well, you have to, number one, find the height. And I always have a problem with GHT, so I hope I spelled that right. Find the height. Find the height of what? Well, what's the only thing you're dealing with? The box, okay? Now, you don't have to find the height with the curve, because you can't find the height with the curve, so you have to do something else, okay? But with the box, with uniform distribution, that's the good thing about time. We can't control it, but we can what? We can predict it, or we can measure it. So, what do? We find the height. Area equals length times what? Height. Yeah, or base times whatever. Area equals length times width. What's the area? 1. Equals length is 50 times wherever you're from, that letter, however you say it. There's 2 pronunciations. W, D-U-B-Y-A, and then there's W. That's the same people that live in Pendleton and Williamstown. Y'all don't know what I'm talking about, do you?
I know what you're talking about.
You don't pronounce Williamstown. You pronounce it Williams. It's got 1 L and don't have a T in it. All right, so the height of this contraption is 158. That's the height, or length, or width, or whatever you want to call it. Now, they want to find out, and they'll either say over 40 minutes, or they'll say under 40 minutes, or they'll say, what is the probability that he'll only teach for 30 minutes? Or what is the probability that he'll teach less than 55 minutes? There's 2 sides of this line. What sides are there? There's the left side, and then there's what? The right side is greater than, the left side is what? Okay, as simple as that. Don't make this what? Complicated. All right, so we want to find, since I put in over, we want to find the area of this rectangle. So somebody tell me what the math is, and that's part 2. So I'm going to go up here, part 2. I'm going to say, okay, the probability of X being greater than 40 minutes is equal to what? Somebody tell me what the math is.
I'm going to be wrong if I say it.
Is it going to be 10 times W?
Where did you get that 10 from?
50 minus 40.
The width right here, good, is 50 minus 40, which is 10. So the base is 10. And what's the height?
150.
There you go. Y'all are so smart. And what's 10 over 50? 10 50ths, which is, well, let's change that to 1 over 5, which is that to change that to tenths, because the decimal would be 0.2. Please don't use a calculator for that. That will just advertise your ignorance. Okay? So, what kind of probability that the teacher is going to go over 40 minutes? A 20% chance or a 0.2 probability. That's how you do these problems. Okay? So we're going to do another one here in just a minute, so therefore you'll have 2 in your notes to pretty much do the test with, unless you just don't write it down there. Question, right, complaint. Y'all see why I use spreadsheet now? I suck at board notes or whatever. I go all over the place. Yeah, just come on in whenever, that's fine. All right, so here we go. Probability of class. Okay, let me start over. Class usually goes $65, or let's see what class. We go an hour and a half, but we're never here that long. But anyway, that's 90 minutes. We'll say 80 minutes or 80 minutes. What is the probability that the teacher will let you out between 70 and 90 minutes? Now, all of these you need to draw a picture, because when we do the curve, you're going to have to draw a picture. What is that noise?
Fire truck.
Okay. All right. I thought somebody was being cute. Today is the day where everybody tries to be cute, and I hate Halloween. But anyway, class usually goes 80 minutes. What is the probability of going 70 to 90 minutes? So here we go. So there's my picture. Here's my graph. Everybody should be able to get this part right. If you miss this part, you don't what? You don't tell anyone. All right, so 0 to what? 80. 0 to 80 minutes. And we want to find out what is between 70 and 90. I'm sorry. 70 and 80, I suck. 70 and 80. Now it's just like the last one. The base is going to be what? 10. But we don't know the height, so we got to go do the height. So 1, that's the 1.0 is equal to length times 80. And of course it comes out to be 1 over what? 80. And that's usually going to be the case. I mean, it's not rocket science. So you take 180, multiply by 10. So, okay, we found the length or the height or whatever you want to call it. Okay, and the 10, so that's going to be 10 over area equals, we're going to try to find this right here. So the area is equal to 1/80 times what? 80, right? No, 10. Okay? And that's going to be area is equal to 10 over 80, which is equal to 1/8. Now, nobody is Rain Man, so now is when you get out your calculator and you say 1 divided by 8 is equal to what? 0.125. So you have a 12.5% chance or a 13% chance that the class is going to go between 70 and 80 minutes. And that's how you do uniform distribution, which will make up Unit 3 tests. You're going to have 2 problems from 6.1, 2 to 3 problems, 2 to 3 problems of 6.2, 2 to 3 problems of uniform distribution. That's 6 problems. I usually give y'all 15 to 20 problems. So what is the rest of it going to be? 7.1 and 7.2, which is normal distribution. Normal distribution is, I don't know, you'll have to look in your book, but let's say if I give you the 10 remaining problems, let's say that's 16, 9 will be normal distribution, normal distribution. That's the dang old curve. Okay, so we're fixing to get into the normal distribution now. Everybody got this? The only thing you got to read is this part right here. What is it going to ask you? Is it going to ask for less than 70 minutes? Is it going to ask for more than 20 minutes? Okay, that's what they're going to ask for. Okay, in this case, they ask more than 70 minutes. Sometimes they may ask between 50 and 60 minutes. It's going to be about the same because 50 and 60 is 10. See what I'm saying? Mm-hmm. Okay, so that's 2 questions. That's good. Okay. Now, let me go ahead and tell everybody what they should do on this section. Okay, for the 2 people that's actually going to do it. All right? Take a piece of paper. Go to Google. And I want you to Google uniform. You can do uniform 2 for the homework. You know, do this for uniform 2. But mainly for normal distribution because you're going to get tired of drawing the diagram. Normal distribution with z-scores. Or you don't have to do z-score. But basically it's going to give you this. 0, 1, 2, -1, -2. That's what it's going to give you. Pick out whichever one you want, whichever one you like. Okay, save it as a picture, and then put it on a word processing document, and put how many? Put like 6 or 8, however big you want it, however small you want it. Print it out and run maybe 50 copies. I mean, 10 copies. Because you're going to get tired of drawing this thing over and over and over again. So this is for the 2 or 3 people that's actually going to do this. All right? Because I know 90% of you, it's a lot of work. You have to right-click, save, and you have to insert and copy and then print. So it's a lot of work. And some of y'all won't do it. And then you'll complain and bitch to me about what?
Having to draw.
There you go. Yeah. All right, so normal distribution. You're going to draw it every time like this. That's why since the beginning I've been telling you to draw it. A lot of teachers don't do that. A lot of teachers, this is when they start doing it in chapter 7. So you know how to do it now. 0, 1, 2, -1, -2. Now there's 2 types of questions you're going to have. The first type, mu is equal to 0. And the standard deviation is equal to 1. That's the first type question, which is going to be probably a lot of 7.1 or the first part of 7.2, and then the second part of 7.2 is going to be the second type question. However, they had it. They used to have it 7.1 is uniform distribution, 7.2 is normal distribution, the first type, and then 7.3 is the normal distribution, second type. And now they condensed them, and I don't know which one's which. Okay? So mu is going to be some other number not equal to 0, okay, and some standard deviation not equal to 1, which means an example would be mu is equal to 100, and the standard deviation is equal to, that's supposed to be sigma. Standard deviation is equal to 25. So here, the standard deviation is 1, the standard deviation down here is 25. So that's the difference in the 2 type questions, okay? Now there's 2 formulas that you have to use in this section, in 7.1 and 7.2, whatever it is. And that is the z-score. Z is equal to x minus x bar over what? Standard deviation, okay? We've learned that back in the last part of the statistics, okay, which is unit 1. The second one you may not have seen before, and that is x is equal to Oz plus mu. Oops. Now the reason I use Oz plus mu is because if you use the sample statistics, which is S and x bar, it would be sz plus x bar, and you wouldn't be able to remember it. But since I'm using oz plus mu, it's easy to remember oz plus mu. I don't know, some of y'all may not remember sz plus x bar. I don't know, but oz plus mu is easy to remember. Now, those two formulas are all you need in this section. All right, so that's where we're going. You've got two type questions, and then we got two formulas that we're going to be using. You're also going to be using your calculator, and we'll show you how to use that. Okay? Like I said, out of all the sections, this is the easiest to make an A on. Some of y'all will mess it up. Area under a curve is 1.0. Okay? We also have to remember the empirical rule. All right? If I tell you this is 1.0, and remember, and I'm going to write this, and this is the way I do with all my statistics classes. 4 decimal places mean area. 4 decimal places means area. Okay? 2 decimal places means z-score. So if I give you 0.25 in a question, you know that's a z-score. Now, the homework will sometimes say the 25th percentile. Well, remember, I've told you this before. P stands for what? Give me the things that P stands for.
Probability.
Probability. What else? Percent. What else? Proportion. If I spell it right. Okay, all of those things, which probability is a decimal. Okay, percent is a percent, you change it into a decimal. Proportion is a fraction that you change into a decimal. So you have to watch sometimes if they put percent what? Percentile. Sometimes they'll say percentile. If it's a probability, if it's a percentile, or if it's a proportion, you got to be careful, okay? Because sometimes they'll say, what is the 25th percentile? You also need to remember your your gas meter or your gas hand. This down here is empty. This around here is what? 25%. This right here is around what? 50%. This around here is around 75%, and this around here is full, which is 100%. You got to remember this. This is 2.5, 13.5, 34, 34, 13.5, and 2.5. So if you're one of those people that don't want to learn stuff, then you're going to be having a problem in this section. Because I told you to learn all of that. Now, what in the world are we going to be doing? Well, the question will ask you for a probability. If it asks for a probability, then you're going to be using the z-score. If it asks for a z-score, you're going to be looking for what? You're going to be looking for a probability. I'll erase that. You're going to be looking at the probability. And when I do a couple of questions, you're going to see. And in case you don't know, probability is area. Probability is percentage. Probability is all that other stuff we talked about. And you need to put area under here too, but it's not with a P. But when you're talking about area, you're talking about all of those things. Question. Okay, so I'm trying to give it to you in little shifts and little pieces, because when we get to the actual doing the problem, I don't want anybody going, huh, what, huh? So I'm going to erase this right here, and I'm just going to go to the whiteboard and do it again. So let me draw another picture. Now, you can use the table instead of the calculator. I'm going to put up here. Table, there's a table in your book. I don't know where it is. You'll have to look for it. It's made out of cardboard, and it has 4 or 5 tables on it. Okay? You'll find it when we get to it. It says Z table positive, Z table negative, or it'll have the Z table and it'll have positive and negatives on it. Or you can use the calculator. There's really no other way to do these. There's no formula except for the 2 that I gave you. As far as looking up the areas are only going to be found in your book, of the table, or with the calculator. So what if I ask for the probability at the z-score? I'll say z is equal to 1.62. Well, as I tell my calculus class and my trig class, first thing you got to do is find out where you are. Okay, so where am I? Well, there's 0, there's 1, there's 2, -1, -2. So you find out where you are. Z is 1.62. 1.62 would be, and we'll take my blue marker, 1.5 would be right in there, so 1.62 would be right in here. Now, is the math police going to come find you if you put it off a little bit? No. You're just drawing this picture for yourself. Okay, so I've got a z-score right there of 1.62. Now, how many sides of that blue line do we have? There's 2 sides. There's a left side and there's a right side. Now, you've got to remember, this is a number line down here. This arrowhead is called negative infinity. This arrowhead up here is called what? Positive infinity. We can't plug infinity into the calculator, so we're going to plug in negative 99999, as many nines as you want. But use more than 3 or more. And this one is going to be 9999. And again, 3 is the minimum. You can use 15 if you want to. All right, it's not going to change the answer. All right, so we need to take a highlighter and we need to highlight this over here. And we need to highlight this over here so you will remember what 9999 means. So Monday you won't come in and say, why are you typing in 9999? All right. Now, the question will ask you, it'll say the probability at 1.62. Or it may ask you the probability that is greater than 1.62. Or it's going to ask you for the probability that is what? Less than 1.62. Now, they may have it worded a little bit differently than I'm showing you, but that's the only probabilities you have. The left side of the blue line, and then the what? The right side of the blue line. So let's take our handy dandy aquamarine, and what is greater than 1.62? I know, but what side?
Right side.
Good job. You're on the ball. So that'll be that area. And I'll take our other handy dandy highlighter and we'll color it verde. And what would be less than? Okay, now you might need your calculator for this. What would be less than? What side would be less than?
The left.
The left. Now, let's go to our handy dandy. If you look in your table, or your table that, you know, if you have a book, look through the table, and when you look at the table, up at the top, it's going to say something to the effect, and what we don't have books, well then you don't need to worry about it. You just need to look at your calculator. Well, what if I don't have both? Well, then you need to beg, borrow, steal because you're going to need it. All right? The table only gives you the left-hand side, and you need to write this down. Table in the book only gives the left-hand side, which means the green. Therefore, 1 minus the left-hand side equals what?
The right hand.
The right-hand side. Okay, so if you don't have a calculator, okay, if you don't have a calculator and you're going to use the book, then you need to write this down over here. Now, if y'all don't ask any questions yet, because I haven't started covering it yet. I'm just giving you the highlights. The table only gives you the green side. To find the blue side, you'll have to find the complement, which is what's the area under the curve? 1. And we're going to do that in just a minute. So, what do we do next? Well, pick one. Well, we're going to pick the blue side. We're going to find the right-hand side. We're going to find this side right here. So I want to find the area right here. Well, let's go back to the empirical rule, because we want to always use common sense, because if we get an answer that says 257, and our common sense answer says 0.35, then we know we've done something what? Wrong. Because our empirical rule says that this is 2.5, right? Right here. And this is 13.5, right? So, I'm going to just go out on a limb here. This right here is our halfway mark. So what's half of 13.5? 6.75, right?
Yes, sir.
Okay, so this is 6.75, and this is 6.75. Everybody with me? And this is 2.5. From our empirical rule, that's why you have to remember the empirical rule. All right, let's see. That's 6.75 on the right. I'm not quite 6.75, so let's knock off the 75, okay? Let's say this area right here is 75, okay? So what's 6 plus 2.5? So I'm going to say, as an estimate, I'm going to go common sense estimate is approximately, what I say, 9%. And we need to write that down because I want to make sure that my answer is going to be somewhere between 8 and 10%. Because common sense wise, I think it's going to be around 9% based on the empirical rule. So what do we do now? Well, those of you that have a table, okay, you need to look up 1.62 on your table. Now, I'm not going to do it because I'll do it. I didn't have enough time to do everything today because my son, of course, made me late. I didn't have anything to do with that. I'm just kidding. We both overslept this morning. So, you go to second bars, and I've got to remember how to do this because I suck at it. And it's called normal PDF or normal CDF. I think it's called normal CDF. We're fixing to find out because I have a common sense answer there. So, normal CDF, enter. And it's going to ask for your lower limit. Now, with the calculator, you don't have to worry about the left-hand side or the right-hand side. You just know from where you want to know the information. So where do we want to know? We want to know the right-hand side, the blue area, right? Yes or no? Okay, so what's our left-hand side of the blue area? 1.62, Hubert. So we type in 1. Well, let me get rid of whatever this is. 1.62. So what would our upper, we read from left to right, so what would our upper be? I heard 9.
9.
Thank you, 9999. And enter, and enter, and enter, and paste, and hit enter. That's 0.05. I said 5%. That could be possible. Okay, we're going to do the other one. I'm going to do normal PDF and make sure. Okay, 5% is good because I was kind of liberal with this right here. So let's see what the other one gives us and see if it's closer to 9%. That was normal CDF. Let me do second bars normal PDF. X value. Yeah, that's not it. Yeah, it's normal CDF because this is only asking for 1x value. I'm going to do 1.62, but that's not going to be right. Paste. Yeah, that's not right. It's not normal PDF, it's normal CDF. So, now I got 9%. The closer, the bigger you are to the bigger areas, the more close you're going to be. But the answer came out to be what? 5.0526. We want an area, so we want to write it in 4 digits. 0.0526. Everybody with me? Now, what if I wanted to know the left-hand side? Well, it'd be $1 minus 0.0526 cents, which is going to be, well, $1 minus 5 cents would be 95 cents, so it's going to be 94 cents. So 0.94 what? 9474? So this would be 1 minus 0.0526, and that's going to equal 0.9474. So what's the green area? The green area is 95%, or 94.74%. Now what did we just find? We found out the probability of a z-score being above 1.62. Now, is anybody ever going to walk up to you and ask you this? No. But the second type question we're going to ask is going to be talking about grades in class. It's going to be talking about SAT scores or ACT scores or IQ scores, and that's where it comes into play, because this base here is not going to be 100, it's going to be 0, it's going to be 100, like an IQ score, and then this will be 130, and this will be 150, or 100, whatever, 130, 160. And then they're going to ask, what is the probability of being above 160? Or what is the probability of being below 90? Okay, then they're going to ask those type of questions. So it's kind of like crawling before you can walk. We got to crawl before we can walk. Capiche? All right, let's do. Now, you got I'll just draw it. It'd be easier to draw it than pull up all the other stuff. If you've got a table, the table is going to be in the columns, and the z-scores are going to be on the outside. Okay? And they're in 2 digits. The body of the table is going to, and it's called z-score. So look for the table that says z-score. They used to have one for negative and one for positive, but I think they consolidated it down to one big one, if anybody's got it, okay? So like up here, they'll have a z right there, and this will be 0.00, 0.01, 0.02, 0.03, ... 0.09. I think of these as the pennies, okay? And this is the dollars over here, okay? 0 point, or the cent, or this is the pennies, and this is the other money, okay?
This is the
I'm sorry, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and what? $1. $1.10, $1.20, ... down to about 3, because after 3, it turns into 99.99% after 3 standard deviations. So it doesn't matter. So it's going to go down to about 3, or 3.5, I think. I can't remember. All right, so this one right here is going to give you pretty much 0% or 50%. Why? Well, if you start in the middle of the graph, right here, if you start in the middle, z-score of 0, what is that? 50%. So it's going to have 0.5500 right there. See what I'm saying? And at 3.5%, it's going to say like, at 3.5, it's going to say like 99.9999 right here. Because 3.5 out here is 3.5, that's 3. Get out of the way. Oh. Whatever. Okay, here's 3.5. What is this over here? What's that at 3.5? 99.99%. Okay, they also got negatives too, and we'll talk about that. But I'm trying showing you how to use the table. Okay, so you got all these 4-digit areas down here. I'm not going to write all those areas. Okay, But the way you use it is you look up 1.62. Well, let's say this is 1.6 right here. You go over, and then you come over to the pennies. This is $1.60. You want $1.62. So, and whatever that 4-digit number is right there, that's your area. But it's to the what? It's to the left of 1.62 on the table. So, does anybody have a table? A Z-score table with them? Nobody?
I can't.
Can't find it. Yeah, it's probably in the back where all the appendices are. Oh, it's a miracle. It's the gas delay. It's the gas in your account. You suck. All right. So look in your table. Look in the Z table. Find the one that says Z table at the top. And and go down to 1.6 and move over and 0.06 and 0.02. And it should say, what was our 0.9 what? What was our 9 what? 974.
974. Right.
9474. Okay, whatever. It'll say something like that. 0.9474. So somebody check that table for him. Somebody beside him, get that table from him. Just take it away from him. What does it say? Does anybody look? I see 2 tables.
You can't find the one that says Z-score.
It's probably the one that says Z table. I'm sorry.
There's one that's table B and it's got a Z.
Okay, go down and find positive 1.6 and then go over 0.02.
9463.
94 what?
63.
Okay, sometimes it's a little bit off. 9463. Okay, now the homework will compensate for that. Okay, the homework, it'll program the calculator area. Yes, sir.
Mine says 0.9474.
Okay. Well, check that. Okay, 9474. Okay, good. All right, but anyway, let me go ahead and tell you this, because some of you will use the calculator and some of you will use the book. If you use both of them, that's fine. But sometimes there's a little bit of a difference, and sometimes you have to use in between numbers. Okay, and I'll get to that when we get to the area. All right, but the calculator, the homework and the test, they put in a calculator answer and they put in the table answer, and it'll take either one of them. Okay, and there's also a little bit of variance on there too, so they make up for that. All right, let's do another one. Let's say that I want to find, and I'm going to go ahead and label everything so you can see. And I want to find the probability less than a z-score of negative 0.52. The probability of a z-score less than 0.52. First thing I'm going to do is I'm going to draw it. 0.52 is going to be right in there, and it's a little bit less than what? A little bit more than what? A little bit more than 0.5. So 0.52 is going to be right in here. So I'm going to just circle this, and I'm just going to draw an arrow right there. Okay? Less than would be to the what? Left. So we don't have to deal with positive infinity. We have to deal with what? Negative infinity, which is negative 9999. Because we're going to find this area right here with the blue. Well, let's use the empirical rule. We know this is 2.5. We know this is 13.5. And it gets easier as you get to the bigger areas because you can tell more. And that's going to be half of 34 is 17. So I'm going to say 15. I'm going to be a little bit more conservative. So that's 15 and what? 16? What's 15 and 16? 31? Somebody add it up for me.
It is.
Okay, so I'm looking at about 31%. So I'm just going to say 30%. or 0.3, is what I think. Now I want you to take your handy dandy calculators. I'm not going to use the table, but you're going to use the table and you're going to look up 0.5, and then you're going to look at 0.00, 0.01, 0.02, and you're going to go down, and where those two intersect, there'll be a 4-digit number, okay? And it's going to be negative. I'm sorry, negative. Look at the negative 0.5, okay? Now I'm going to take my handy dandy calculator, and I'm going to hit second. I got to turn it on first. Second, bars, normal CDF. I think it was CDF. And I'm going to type in negative 9999, because we read from left to right. And it doesn't matter how many you put. Upper, what's the upper side? Negative 0.52. That's why it's so important when you draw a picture. When I get to the in-betweens, the picture is going to make a lot of difference. Okay? And go to paste. 0.03. Okay, I've 1.62.
That was from the last one, you never did it.
Oh, I'm sorry. I suck. Second, enter. Okay, so did I type it in right? Yeah. Well, why didn't it do
I
it?
did it and I got 30. Yeah, I got 0.3015.
Yeah, that's what I
Oh,
did.
it's a normal PD.
Yeah, you did
not
PD.
CD.
Oh, did I type in the wrong
You did PD. That's all it is.
CDF, right?
Yeah.
Normal CDF, 999.52. I must not have pasted. I don't know. There. What the? I don't know.
That's right.
All right, see, I said 30%, and it is 30%. But you don't write 30, you write 0.3015. Now, somebody with the table, tell me what you got.
It's the exact same.
The exact same. It's a miracle. 0.3015. Now, what if I wanted the right-hand side? And this is just so some of y'all with the table, I want the right-hand side, which is greater than negative 0.62, would be 1 minus 0.301. Please don't use a calculator. If you don't know what $1 minus 30 cents is, it's about 70 cents. So it's going to be 0.69, what, 85? Please don't use a calculator for that. Do it at home. Nobody will see you do it, okay? 0.6985. So 70% pretty much is on the right side and 30% is on the left side. Capiche? Now, so far, we've done 2 easy problems. Now let's do an in-between. Now, before we do an in-between, let me ask you a question. Let's say you're in Anderson and you want to go to Spartanburg. Okay? Now, this is supposed to be a very easy question, so don't think you're ready to create the space shuttle because you answered this question, all right? Because some of y'all. Anyway, you're going to start right here, and you're going to go to Spartanburg, and from Spartanburg to Anderson, I'm going to say is 100 miles. Okay? And then you know that Greenville is 40 miles. Okay? Now, I know how far it is to Greenville, and I know how far it is. I'm just using these numbers. So I don't need some essay to say, oh, well, it's really 123 miles. Shut the hell up. Okay? I'm using rounded numbers here. Instead of 35, I'm using 40. Okay, 100 minus 40. What is that 100 minus 40 going to give me? It's going to give me 60, which is from Spartanburg to what? Greenville, or from Greenville to Spartanburg. What did I do? I took the larger amount and I subtracted the what? The smaller amount. Write that down because that's what you're fixing to do with the area in between. Now, am I talking to the people with calculators? No. But people with tables, you know, and this in 10 years probably will be teaching this because everybody will be doing it on the calculators unless all the calculators go away and people have to really think. Okay? Then they can make changes at the cash register when people have to start thinking. All right, so here we go. Let's say that I want to find the area, and I'm gonna go ahead and see why you gotta print these out. This gets old. I've already drawn this thing like 6 times. I want to find the area, and I'll call it X, between negative 0.5 and positive 0.78. And this is where you say, well, I just go to the next problem. Okay. Well, first of all, I'm going to do the 0.5 in red, and I'm going to do the 0.78 in blue. Now, I'm going to show you the theory behind it, and for the people that use tables, I'm going to show you that. The people that sleep with their calculator and have it a name and sacrifice live animals to it, you don't need to know this because you're not going to listen anyway. So, negative 0.5 is right here. Everybody agree with me? So that's the distance from Anderson to Greenville. And then this is the distance from Anderson to Spartanburg. What do I want? I want the distance right in here. Oops, sorry. So to get the green area, what do? I take the red area from the blue area, and that will leave for what? The green area. The distance from Spartanburg to Greenville. Everybody see what I did? And to make it clearer for some of y'all, this is Anderson, this is Greenville, and this is what? Spartanburg. I take the big one and I subtract the smaller one. Now that again is only if you use the table. Because if you don't use the table, if you use a calculator, you just go from what? 0.5 to what? 0.78, Hubert. And it'll give you the answer. But we're going to do it with so I want somebody with a table to look up 0.5 for me. And luckily it's just negative 0.5 because I tried to make it simple for you. Give me the 4-digit number.
3085.
Wow, you actually didn't mumble like other students do. You ought to listen to my voicemail. I just delete them.
Can we?
Huh?
Can
No. No, you wouldn't want to. Anyway, I just delete it. There's 2 or 3 things y'all need to learn to do for real world, okay? One is when you knock on a door, how do you knock? No, this is the way you knock. No. You knock on the dadgum door. Second thing you do is when you talk, you don't talk like mush mouth on Fat Albert, okay? You articulate and you speak. This it ain't cute after about 5th grade. Annoying. Y'all know what annoying is, right? N-O-Y-I-G, annoying. Annoying. Yes, annoying. Annoying. Clemson. Okay, I'm just kidding. All right, so the blue. Now I'm gonna write the blue. We'll write the blue. Somebody give me 0.78. What is 0.78?
Oh, I'm doing 0.7.
With the table.
0.7823.
0.7823. So somebody take your calculator and take 7823 and minus 0.3085. Notice I said use your calculator because you're not Rain Man, but you do know 78 cents minus 30 cents is 58 cents. So it's going to be 56, 55, 40 something. What is it?
0.4738.
Okay, I got it way off. What?
0.4738.
4738. How can that be? 78 minus 30 cents. Okay, I'm sorry. I'm thinking of 50 cents. Okay, shut up, Hubert. I'm sorry, I was thinking something else. All right, I just can't add, that's what it is. Now, some of you that have a handy dandy calculator with normal CDF, let's go ahead and punch it in, if I can do that, which is not letting me do it. There we go. And I'm just gonna type in second, enter, and I'm gonna go over here. And I'm gonna type in negative 0.5. And to keep from having to delete, I'm gonna type in that, 0.5, like that. And then 0.78 and 0, don't, well, I just messed it up. I suck. Insert, comma, there, how about that? And enter. 0.4738, it's a miracle. 0.4738. And you notice they're both the same. And they're going to ask you, in the homework and the test, they're going to ask you to round to the fourth digit. And that's what I did. And it came out to be exactly the same. 90% of the time, they'll come out exactly the same. The other 10% of the time is when they're between numbers. And I'm going to talk to you about that here next. Let me make sure that you're not going to explode. Okay, this 9:20, okay, we'll go ahead 1 more minute. Now, I'll wait, we'll go over that, because we're going to go over this 2 or 3 days. We're going to go over this next week, Monday and Wednesday, and I'm going to call the roll here in just a second. Monday and Wednesday, I'm going to do it for a couple, 3 weeks, keep them happy, and then the next week. Okay, so, because we have perfect attendance.
We don't have class on Monday.
What's Monday? What's what?
Already.
Okay, good. Okay, Wednesday. All right, let me take the roll, and then y'all can skedaddle.
Yeah, it's actually Christmas.
I got to take the roll. Did y'all hear me?
Yes, sir.
I got to legitimately do this, okay? So y'all can complain about it and tell them I did it because we got perfect attendance. And let me stop the recording too.